This is our third lecture discussion for M27. This revolves around the virtual machine. Once again, if you have not watched the lecture discussion for the virtual machine, you need to watch that first. Then you need to watch the set logic discussion, then the set reset logic discussion, and then this one, because they build on each other. If you don't understand the virtual machine and how it functions, this won't make a whole lot of sense. So be sure you watch those three first. It doesn't hurt to go back and review them if it's been a while since you watched them. In this discussion, we're going to talk about seal-in logic, which is the more difficult to write, but the easier to troubleshoot and maintain. And it makes the most sense. The first one we did was set logic, where we set bits to say steps were complete, and then we predicated completing step 2 on the fact that step 1 was complete, and then when 2 is complete, then we execute step 3, when it's complete 4, and so on. But we left all of them set to complete until we got all the way to the end and the finished part was out of the cell before we reset those so we could start working on another part. Then in the second logic with set reset, we reset step 1 complete when step 2 was complete, and when 3 was complete, we reset 2. That way we're opening the trail behind us for more parts to come into the machine. In this discussion, there won't be any latches, unlatches, set, reset. If we do use one, it'll be in a situation where it really makes sense. But out in the field, latches and unlatches are bad news. Again, latch and unlatch is the easiest way to write a sequence. And in the beginning, that's probably what you're going to do. You're probably going to use set, reset, or latch, unlatch. And then as you get more experience, you're going to start seeing the problems and you're going to start thinking through the logic well enough that you can have autonomous rungs of logic. So let's jump in there and do this. For the most part, the logic looks the same. The very first rung is identical in all three types of programs. When input 0 comes on, that means there is a part that has entered the optical path of photo I1. And we want to trigger the barcode reader to scan the part and identify its part number. If that part number, when identified, is greater than 5,000, then we say there's a new part queued. All that means is that the part is now traveling in between photo I1 and photo I2, and it's been identified as a part that we want to bore a hole in. So everything else takes place once the part reaches photo I2. So rung 1 was the barcode trigger scan. Rung 2 was the analysis of the part number to see if it was a part that needs a hole bored in it. So new part queued means that this part now coming between photo I1 and 2 needs a hole bored in it. So if we have a new part queued, we also have added some logic here for a timeout. In other words, let's say that someone runs their hand in front of the photo eye. That won't scan in a part number. So it'll ignore that. You won't have a new part queued. But let's say a part is scanned, and it is a part that needs a hole bored in it, and for whatever reason, someone reaches in and grabs it off the conveyor in between photo I1 and photo I2, or something gets jammed. Well, we have a timeout of 10 seconds in rung 3. Once a new part is queued, if the part queue timeout completes the 10 seconds, then it moves a 0 into the part number. And we also clear the part number if similar to extended proc switch is made, input 12. That's also a change from the other logic. In rung 4, with the new part queued, and the photo eye 2 seeing that part that's cued, and there is no part at photo eye 3, part present, sonar 2 into stroke. Now that's also something relatively new, and that is that right now the instruction's true, but the bit is off in memory, which means there's no part at the end of stroke for sonar 2 that would get in the way for you to bring in another part. So if a new part is cued and photo eye 2 sees it and there's not one already in there, then we're going to extend sonar 1 and sonar 2. Then in rung 5, once sonar 2 is extended, and keep in mind we're extending 1 and 2 together, so you could say sonar 1 extended prox would do the same thing. But we're leaving these two cylinders with separate controls, even though we're combining them into the rung, in case later on you decide to do something different with cylinder 1. Right now they're working together. Whatever cylinder 2 does, cylinder 1 does. Okay, so rung 5, input 12 is sonar 2 extended prox switch. Now don't forget that input 12 is not the hardware input 12 on our simulator. It is a simulated input from the cylinder logic that provides a delay between when the solenoid is energized and when the prox switch says that the end of stroke has switched from retract to extend or vice versa. Okay, back to 5, rung 5. Once cylinder 2 is extended, then we turn on the drill motor, energized drill motor. Now notice that our output instructions now are not set. They're just energized output. So as long as cylinder 2 is extended, the drill motor is on. After the drill motor's been on for 3 seconds, then we extend cylinder 4. So we give the drill motor 3 seconds to get up to speed before we extend it. That's a little different than the previous logic, but the same idea. In rung 5 here, you see that the output for cylinder 4, extend cylinder 4. Now remember, these are still single solenoids. So you turn on, extend cylinder 4, it extends, you turn it off, it retracts. If cylinder 4 is retracted, if we're telling it to retract, then we want extend cylinder 4 to go off. So that retract cylinder 4 is in the following rung because it comes after extend. We extend it before we retract it. So if we scroll down a little bit and look into the next rung, 6, you'll see that if cylinder 4 is extended, it starts a timer for 3 seconds. So we leave cylinder 4 extended with the drill bit spinning for 3 seconds, and that's to give it time to auger out any debris out of the hole. So we keep the bit spinning. It also does assist the bit in cooling somewhat. It cools better spinning than it does sitting still because you have a little forced convection because the flutes on the bit, if you want to call them the grooves, it kind of acts like a centrifugal blower and it sucks air in and spins it out by centripetal force. You may like centrifugal force. We retract cylinder 4 and we seal in the retract cylinder 4 until cylinder 4 is retracted. So if you look down below, when the retracted prox switch goes off, as long as it's off, then that will be true. So we're going to have to see this in motion. So going through all this logic without actually executing it does give you a little bit of a struggle. In rung 7, if cylinder 4 is retracted, then we use a trigger, rising trigger, to say that the boring is complete. And the boring is complete right here in rung 7. That's used back up here in rung 4 to cause cylinder 1 and 2 to retract. So technically they'd be on right now, and when the boring is complete, this goes false, and we no longer have this sealed in. Okay, boring complete, and we want to extend cylinder 3 now once the boring's complete. So if there is a part at cylinder 2 into stroke, remember that this was turned on in an earlier rung once cylinder 2 had extended and there was a part at cylinder 2 into stroke. So if that's true and cylinder 2 has retracted, so cylinder 2 retracted and left the part there. So it's still true. True. There's no part at photo I4, which is the end of cylinder 3 into stroke. In other words, there's no part in the way. And if cylinder 2 retracted proc switch is true, I know this seems a little confusing here, but it works. And we're not extending cylinder 1 and 2, then we extend cylinder 3. It seals itself in, and as long as cylinder delay retract cylinder 3 is not complete, that's right here. So once cylinder 3 extended proc switch is made, then there's a 3-second delay before we retract cylinder 3. So when we retract cylinder 3, it's because this timer timed out, and this timer timing out here in the rung above, this is going to go false, and that's going to drop out, extend cylinder 3, and cylinder 3 is going to retract. So this is getting complicated to explain without executing it, so let's execute it. To execute it, let's go to the HMI program file. Now keep in mind that there's nothing here controlling anything. These are all instructions that allow us to see the state of those bits in memory. Notice that there are no output instructions. You see a lot of true if on, you see some true if off, and then you see a number of any to lint. That's a long integer. LINT is long integer. And what the any to lint allows us to do, take the first one in rung 2. It allows us to see the value for the timer that is delaying the extension of cylinder 4. That's all in there just so you can see that value. Delay extend cylinder 4 ET. There just isn't any other way to display it other than to use an instruction like this. So the any to lint will take any data type and convert it to a long integer. In this case, we're converting the elapsed time from those timers to an integer that we can display. So 3,000, that's 3,000 milliseconds. And when we execute this logic, you'll be able to see this. Now, the first 6 rungs are the detailed approach to this. I'm calling it an HMI because it's your human-to-machine interface. Rungs 7 and 8 are a little bit more condensed. So right now I can see that cylinder 5 is extended. You can see over here output 5 is on the simulator. That's because we have no downstream call. Now the downstream call in the logic that controls cylinder 5 is unconditional. So watch output 5 and input 5. If I turn it on, it goes out. If I turn it off, it goes on. So this controls cylinder 5 unconditionally. If you have a downstream call, you're going to retract cylinder 5. That's going to let parts go on down the finished product conveyor. So let's leave that off and let's start this process. First thing I'm going to do is turn on input 0. Picture a part passing in front of photo I1, triggers the barcode trigger, we get a new part queued, we turn it off. That's because the part passed on through photo I1. It's now in between photo I1 and photo I2. So the next thing we're going to do is turn on photo I2. And you can see over here photo I2 turns on, and we're going to extend cylinder 1, cylinder 2. I see that nothing happened and we don't have a new part queued. Well, that's a good point, and I know exactly what it is. I'm going to go to outputs and make sure that auto mode is turned on, then go back to sequence go back to HMI. I'm going to reset this back to the beginning, and I'm going to do this again. Photo I1, we got a new part queued. Photo I2, we extend cylinders 1 and 2, and after delay, the extended proxies come on. And now, extended cylinder 4, turned off the drill motor. See, this goes through way too fast to follow it. So all you can do is let it go and see where it ends up. So let's look down here at the bottom. This is easier to look at. If you wanted to put in those single step bits like we did in the last lecture, you could do that to slow this down. I'm not going to. I'm going to let you do that. So where are we at right now? Where's the parts at? I see photo I3 says that that bit is on. Cylinder 2 end of stroke. I see cylinder 3 end of stroke. I see the output conveyors on. So I need to turn on, and this should not be on. Now see, that's the problem with toggling bits on and off from the simulator. So I'm going to go back and do that again correctly. So keep in mind you got to turn on input 0, which is photo I1. Once you got a new part queued, turn it off, then turn on photo I1, and once you're extending cylinder 1 and 2, turn it back off. Otherwise, it's going to bring in another part right behind this one, because remember, this logic allows you to have more than one part in there at a time. So we only have one part, and right now it's at cylinder 3 end of stroke. We've not turned off this yet until we clear this. So let's say that the conveyor is on. See, finished product conveyor is on. Let's turn on input 4. And that means the part has arrived there. Notice the first thing we're going to do is remind ourselves what controls cylinder 5, which, remember, cylinder 5 was installed at the behest of the downstream station so they could control whether or not parts were leaving this station and going on down to them. They don't want them. They wanted some way to prohibit that. When we look at the downstream call, which is input 5 down here, if we were to look at the logic, you would see that input 5 unconditionally controls output 5. Now, it's just a coincidence that it's input 5 and output 5. So if I turn on input 5, watch output 5 down here. It immediately goes out because when there's a downstream call for parts, then output 5 is de-energized. It's a spring return single solenoid, so the cylinder retracts to allow parts to go on downstream. We'll turn off the downstream call and leave cylinder 5 extended. First, let's do a reset. So input 7 is our reset. Turn it on, turn it off. Now I'm going to turn on input 0 and watch over here. See, input 0, photo I1, new part. You can also watch down here, so it's easier to look at these two rungs down here. So I'm going to turn on input 0 and watch down here. It'll say that input 0 is on and this instruction is true. Remember the color of the instruction: blue, false, red, true. The color of the memory location: red, on, blue, off. So it's turn on 0. And if you look down there in rung 7, you see there's a new part queued. So we turn input 0 right back off, and we still have a new part queued, and we're in a timeout. So now we have to turn on input 1. You can see down in rung 7, input 1 comes on. Input 1 comes on, we turn it off. You see that cylinder 2 is extended. We have a part at cylinder 2 end of stroke. The drill motor is running. We've extended cylinder 4 to push the drill motor into the part. Now cylinder 4 is retracted, and we are extending cylinder 3, and it has pushed the part out onto the finished product conveyor. So we have a part at photo I4, part present, cylinder 3, end of stroke. Remember that some of these photo eyes are virtual. In other words, we're not actually turning them on and off See, here you see input or IN00, IN01. Those are inputs up here on our simulator. Here, these two photo eyes, they're simulated and we're using logic to simulate them. So right now, the part has been pushed out onto the finished product conveyor. And when we retracted cylinder 3, that was the logic that allowed us to say that there was a part at PE4. But the conveyor is running, so guess what? The part's not going to sit there. But right now, that's what it's showing, simply because we haven't acknowledged that it ever reached photo I5. So theoretically, the instant that this comes on and the finished product conveyor is running, that part is moving out of photo I4 and it's going to go down and block photo I5. However, because this is not a real photo eye, we're simulating it, this won't go off until it arrives at photo I5. So I'm going to go up and turn on 4. And when I do, this bit is reset and it turns off the finished product conveyor, because remember that we have cylinder 5 extended. So there the part sets and the finished product conveyor is off, and this sits there until another part comes in. So let's bring in another part. So they're going to turn on input 0, that's photo I1, and then back off. Now we're going to turn on photo I2 and back off. And so now you can see it's cycling through, and we still have cylinder 1 and 2 extended. It still says there's a part present at cylinder 2 into stroke. Now you see that does go out as soon as the part arrives down here at cylinder 3 into stroke. But notice that the finished product conveyor did not come on because photo I5 is already blocked. So there's no place for the part to go. So as soon as it arrived on the finished product conveyor and this bit was set, the simulated photo I4, it turned off the conveyor. So it sets right there. Now that means the next part cannot be pushed out onto the conveyor by cylinder 3. So let's check that out. Let's turn on input 0, photo I1, back off, turn on input 1, which is photo I2, and back off. So you see it's drilling the part right now, but you will not see cylinder 3 extend because there's nowhere for that part to go. So now when you look at your HMI rungs down here, if you look at them in order, you see part present, cylinder 2 into stroke. Well, that's right in the V block where you bore the hole in it. Part present, cylinder 3 into stroke. That's where it got pushed out on the conveyor, and then there's one in front of photo I5. Now, if I were to turn on a downstream call, we would expect these parts to start moving. So let's do that. Okay, now I'm going to have to operate input 4 because input 4 is photo I5. I can't just leave that on and leave it off. I have to operate it as if the parts are moving. So I'm going to turn on the downstream call, which is input 5, and I'm going to pretend that it left the photo I5. So now the part can leave the into stroke cylinder 3 and then arrive at input 4, photo I5. Notice that we turned off part present cylinder 2 into stroke and turned on this one again. That one went off and then back on when cylinder 3 pushed the part out onto the finished product conveyor. So now let's turn off input 4, which is photo I5, and let's turn it back on again. And now the part has arrived at input 4, photo I5. Now the conveyor is running, the cylinder is retracted, so it would have just passed right on through the optical path of photo I5. So let's turn that back off. Whoops, I turned off the wrong thing. I turned off the downstream call. Turn off input 4, but I left on the downstream call. So the conveyor is running. Now if we put a part in there, let's do input 0, new part, input 1, extend cylinder 1 and 2, and see where it ends up. See? Cylinder 2 into stroke. We're drilling it, and it's going to push it out onto See, extend cylinder 3, part present, cylinder 3 into stroke, conveyor comes on, and now we have to acknowledge that it moved from here to here by turning on 4. Okay, notice the conveyor does not stop. It passes right on through photo I5 and on downstream it goes. And folks, that's all she wrote. Again, if you don't have a picture of this virtual machine in front of you while you're watching and listening to this lecture, it's not going to make a whole lot of sense. That is in part 2 of the CCW manual. Thank you for watching. By the way, this video will probably eventually end up on another platform that's not free. It'll be part of a subscription.